Hello friends, welcome to my lecture on Big M method, first lecture on Big M method. This method was given by a chance and it consists of the following steps. First we express the problem in the standard form. Okay. So, by expressing the problem in the standard form means we first put the problem in the maximization form, okay, and then the second thing is that we ensure that all the BI's in the constants are non-negative. Third thing that we have to do is that we have to express all the constants in the form of equations by using slack or surplus variables. The fourth thing is that we have to see that all the variables in the problem are non-negative. So, first we put the problem in the standard form, then the second step we do is that we add non-negative variables to the left hand side of all those constants which are of greater than or equal to type. Such new variables are called artificial variables, and the purpose of introducing these variables is just to obtain an initial basic feasible solution. So, these variables are causing violation of the corresponding constants. So, therefore, we would like to get rid of these variables and would not allow them to appear in the final solution, and that is why we assign a very large penalty minus m to these artificial variables in the objective function. So, purpose of introducing artificial variables is just to obtain a initial basic feasible solution, but they violate the corresponding constants. Therefore, we would like to get rid of them and also would not allow them to appear in the final solution. Now, what we do is let us solve the modified LPP by using simplex method. At any iteration of the simplex method, the following three cases may arise. First case is that there remains no artificial variable in the basis and the optimality condition is satisfied. Then the solution is an optimal basic feasible solution to the problem. The other case could be there is at least one artificial variable in the basis at 0 level, that means 0 value in the V column. The artificial variable having 0 value in the V column and the optimality condition is satisfied. Then we say that the solution is a degenerate optimal basic feasible solution. Now, the third case is there is at least one artificial variable in the basis at non-zero level, that means with the positive value in the V column and the optimality condition is satisfied. Then the problem has no feasible solution because the artificial variable there is at least one artificial variable in the basis at non-zero level, and so the final solution is not optimal because the objective function contains an unknown quantity m. Okay. Such a solution satisfies the constants, but does not optimize the objective function, and therefore is called a pseudo optimal solution. Now, we in the step 4 we continue the simplex method until either an optimal basic feasible solution is obtained or an unbounded solution is indicated. Now, let us consider this example and solve this example by using Charney's method. So, use Charney's penalty method to minimize z equal to 2 x 1 plus x 2 subject to 3 x 1 plus x 2 equal to 3, 4 x 1 plus 3 x 2 greater than or equal to 6, x 1 plus 2 x 2 less than or equal to 3, x 1 x 2 greater than or equal to 0. Since this equation LPP is of minimization type, first we convert it to maximization type, and therefore consider we consider maximum of z dash. Z dash is minus z. Okay. Z dash is minus z. Okay. So, z is equal to 2 x 1 plus x 2. So, minus 2 x, this is minus 2 x 1 minus x 2, and then we assign 0 values to the because the first constant is of the type equality 3 x 1 plus x 2 equal to 3, this is first constant. Second is 4 x 1 plus 3 x 2 greater than or equal to 6, x1 plus 2 x2 less than or equal to 3. Now, this is of equality type. So, we have to add a artificial variable here, okay, and here this is of greater than or equal to type. So, we add one we subtract surplus variable S1 let us say, and add an artificial variable here, and here we add a slack variable. So, let us say we have this is your surplus variable S1, this is your slack variable S2, and A1 and A2 are artificial variables which have been given the value -1, that is the penalty minus m. Okay. So, the equations first equation 3x1 plus x2 equal to 3 can then be written as 3x1 plus x2 0s1 0s2 plus a1 plus 0a2 equal to 3. Okay. We are adding a artificial variable here. Now, second constant is 4x1 plus 3x2 greater than or equal to 6. So, we consider we take a surplus variable and we subtract this surplus variable here. So, 4x1 plus 3x2 minus s1 and then 0 s2 0 a1 and then a2, because it is greater than or equal to type. So, we also have to take a artificial variable which we can take as a2 equal to 6, and then third constant is less than or equal to type. So, x1 plus 2 x2 less than or equal to 3. So, x1 plus 2 x2 0 s1 and then we take s2 here plus 0 a1 plus 0 a2 equal to 3. So, s2 is the slack variable here. Okay. So, we have and we take a1 x1 x2 s1 s2 a1 a2 to be all non negative. Okay. So, thus we consider the corresponding maximization problem, okay, where we have to maximize z dash equal to minus 2 x1 minus x2 plus 0 s1 plus 0 s2 minus m a1 minus m a2, okay, subject to these equations, these three equations, where the variables x1 x2 s1 s2 a1 a2 are all greater than or equal to 0. Okay. So, the second and third inequalities, okay, are converted into equations by introducing surplus variable and slack variable. Okay. And first and second constants, this one and this one, okay, they were of equality and greater than or equal to type. So, we have introduced two artificial variables a1 and a2. Okay. Now, let us go to finding initial basic feasible solution. Okay. So, surplus, now let us note that surplus variable S1 is not a basic variable here, this surplus variable S1, okay, is not a basic variable here, because if we take x2 x1 x2 s2 a1 a2 equal to 0, if we take x1 equal to 0 x2 equal to 0, okay, and s2 equal to 0 a1 equal to 0, okay, then what a2 equal to 0, okay, then what we will get s1 equal to minus 6. Okay. So, taking x1 equal to 0, x2 equal to 0, s2 equal to 0, we have three equations here, and there are how many constants? 1 2 3 4 5 6 constants. So, we need to take 3 constants equal to 0. So, we can take s1 x2 equal to 0 and a2 equal to 0. See, we have three equations here 1 2 3. Okay. So, to obtain initial basic feasible solution, we need to take 3 constants equal to 0. So, that means let us take x1 equal to 0, x2 equal to 0, a2 equal to 0. If we take x1 equal to 0, x2 equal to 0 and a2 equal to 0, then we arrive s1 at x1 equal to minus 6, but s1 is greater than or equal to 0. So, what we have as s1 will not be a basic variable, because its value is minus 6. Okay. So, as negative quantities are not feasible, s1 must be prevented from appearing in the initial solution. Okay. For a feasible solution, all the variables must be non-negative. So, here s1 must be prevented from appearing in the initial solution, and this we can do by taking s1 equal to 0. So, by setting the other non-basic variables x1 x2 each to equal to 0. So, what we do now? We take x1 equal to 0, x2 equal to 0 and s1 equal to 0. Okay. x1 equal to 0, x2 equal to 0 and s1 equal to 0, we obtain the initial basic feasible solution as x1 equal to 0, x2 equal to 0, s1 equal to 0 and then we get a1 equal to 3, a1 equal to here you see x1 is 0, x2 is 0 and then we are taking s1 equal to 0. Okay. So, we get a1 equal to 3, we get this equation gives you a1 equal to 3 okay, and here we get x1 0, x2 0, s1 0. So, a2 equal to 6 okay, and we get x1 0, x2 0 and yeah. So, x1 0, x2 0 and this what we had here we have s2 equal to 3 okay, x1 plus 2 x2 plus 0 s1 plus s2 plus 0 a1 plus 0 a2 equal to 3 gives s2 equal to 3. So, what we have is this the initial basic feasible solution is x1 equal to 0, x2 equal to 0, s1 equal to 0, a1 equal to 3, a2 equal to 6, s2 equal to 3 and we then have the initial simplex table as. So, these are CJs. CJs are the coefficients of the variables in the objective function. So, x1 coefficient of x1 is minus 2, coefficient of x2 is minus 1, coefficient of s1 is 0, coefficient of s2 is 0, coefficient of a1 is minus m, coefficient of a2 is minus m. These are the coefficients of x1, x2, s1, s2, a1, a2 in the objective function. The basis is a1, a2, s2 okay. Basis is a1, a2, s2, this one. Basic variables are a1, a2 and s2 and non basic variables are x1, x2, s1. So, non basic variables are x1, x2, s1 okay. Basic variables are s2, a1, a2 and these are the coefficients which we have written from the constants, the equations, these equations, this equation, this equation and this equation, first equation, second equation, third equation. So, the coefficients of x1, x2, s1, s2, a1, a2 are written here 3, 1, 0, 0, 1, 0, 4, 3, minus 1, 0, 0, 1, 1, 2, 0, 1, 0, 0 and these are the this is the B column okay. B column is your 3, 6, 3 that is B column. Now, the coefficient of a1 in the objective function is minus m. So, under CB column we write the coefficients of the basic variables. So, minus m, the coefficient of a2 is minus m and coefficient of s2 is 0. Now, we calculate zj equal to sigma CB aij okay, sigma CB aij and we can so then let us see this is your CB column. So, minus m into 3. So, we get minus 3 m, minus m into 4 we get minus 4 m and then 0 into 1 is 0. So, we get sigma CB aij is equal to minus 7 m, then sigma CB aij we find for the second column okay, x. So, minus m into 1 minus m into 3 minus 3 m and 0 into 2 is 0. So, we get total minus 4 m. So, this is minus 4 m and then we write similarly minus m into 0 is 0, minus m into 1 is minus m, this is 0 into 0. So, we get minus m into minus 1 is m. So, we get m here okay. Similarly, this column S2 minus m into 0 is 0, minus m into 0 is 0, 0 into 1 is 0. So, total sum is equal to 0 and then minus m into 1 is 0, minus m into 1 is minus m, minus m into 0 is 0, 0 into 0 is 0. So, sum is minus m okay. So, we get here minus m and then minus m into 0, minus m into 1, 0 into 0. So, we get sum as minus m okay. And then here when you multiply minus m minus m 0 to the B column we get minus 3 m, minus 6 m and then 0. So, total is minus 9 m okay. Now, we find Cj, capital Cj equal to a small cj minus zj. So, this is your Cj. So, and this is this is our zj okay. So, minus 2 minus of minus 7 m gives you 7 m minus 2 okay. So, minus 2 minus of 7 m gives us 7 m minus 2. Similarly, minus 1 minus of minus 4 m gives us 4 m minus 1 and 0 minus m, 0 minus m is minus m. So, we get minus m here, then 0 minus 0 is 0, then minus m minus of minus m is 0. So, we get 0 here, then minus m minus of minus m is 0. So, we get 0 here. Now, let us see. So, C j is equal to C j minus Z j. Okay. In here it is 7 m minus 2, here it is 4 m minus 1, here it is minus m. Okay. M is a very large quantity. So, we see that C j is positive. Okay. C j is positive in this column, column corresponding to x 1 and column corresponding to x 2, but since m is large, 7 m minus 2 is more than 4 m minus 1. So, maximum C j, okay, is 7 m minus 2. C j is positive, C j is positive, okay, in the two columns, in the columns corresponding to x 1 and x 2. Okay. But since m is large, 7 m minus 2 is more than 4 m minus 1. So, 7 m minus 2 is our key column, this is our key column, okay. And then what we have to find the key row. Okay. So, the elements of key column, okay, we divide to the elements of B, okay, the B column, okay, the elements of B column are divided by the corresponding elements of key column. So, 3 over 3 gives you 1, and then 6 over 4 gives you 3 by 2. So, this is 1, this is 3 by 2, and then 3 divided by 1 is equal to 3. Now, we have to find minimum of these 3 values. So, minimum is clearly 1, okay, and therefore, this row, okay, this row is key row, this row is a key row, okay, where this arrow shows the key row, and at the intersection of key column and key row we get the key element. So, this is our key element. Okay. So, we have the following. Since C j is positive under x 1 x 2 column, this is not an optimal solution. Okay. We therefore iterate towards finding optimal solution, and what we do then, we have found the key element. Okay. Now, key element we divide by the key element all the elements of the key row. Okay. So, to get here 1. So, we divide this key row by 3, we get 1 here, 1 by 3 here, 0 here, 0 here, 1 by 3 here, and 1 here. Okay. So, we get that 1, 1 by 3, 0, 0, 0, 1. Okay. So, we divide the elements of the key row by the key element to obtain this key element as 1, and then we use elementary row operations to make all the other entries in the key column equal to 0. Okay. So, by using now this what? This is 4. Okay. So, we multiply this row by 4, okay, key row by 4, and subtract from the second row to have 0 here. Okay. And then to get 0 here, okay, we subtract the key row, this row from the third row. Okay. So, what we do after dividing this key row by 3, we make the element 3 as 1 here, and then with the help of this 1 we make the elements in the key column, that is 4 and 1 0, using elementary row operations. To make 4 0, we have to multiply the elements of this key row by 4 and subtract from the second row, and then to make this 1 0, we subtract the elements of the key row by the elements of the key row from the elements of this third row after the key element has been made 1. So, that we have to do here. So, key row after dividing by 3 becomes 1, 1 by 3, 0, 0, 0, 1, and then we subtract 4 times of this from the second row, we get 0, 5 by 3. How we get 5 by 3? We can see, this is 1 by 3 after dividing by 3, this becomes 1 by 3, and then we multiply it by 4 and subtract from this. So, we will get what? 3 minus 4 by 3. 3 minus 4 by 3. Okay. So, that means 9 minus 4 by 3. So, 5 by 3. So, this element, this will become 0, this will become 5 by 3. Here we will get minus 1, minus 0 into we are dividing by 3. So, 0 by 3 is 0 and then multiplying by 4. So, 0 into 4. So, we get minus 1. So, this element will remain minus 1. This element here will also remain 0 because we are dividing this row by 3 and then multiplying by 4 and subtracting from this row. But here what will happen, this is 0, we are dividing it by 3, okay, and then multiplying by 4 and subtracting. So, 0 minus 4 by 3, okay. So, this will be minus 4 by 3. So, this A1 element here will be minus 4 by 3. So, what we do is now what will happen is that this is incoming variable, x1 is incoming variable and A1 is outgoing variable. Okay. So, in the new simplex table, okay, A1 be replaced by x1 and the value, the coefficient of x1, that is minus 2, will come in place of minus m. So, here we get minus 2 and then A1 is replaced by x1, okay. A1 is replaced by x1 and the column corresponding to A1 is deleted, okay. There is no column in the new simplex table corresponding to A1, okay. A1 is the artificial variable, we want to get rid of A1 as quickly as possible. So, after writing this incoming variable x1 and the corresponding value in the CB column, we make this element 1, we make this element key row key element 1 and then subtract it from the using elementary row operations from the second and third rows to make this 0 and this 0, okay. And what we get is this, yeah. So, we have A1 is column corresponding to A1 is not there, A2 we have to look into. So, 1 minus 0 by 3 into 4 into 0 by 3. So, we get 1 here. So, we get 1 here, okay. And then B column, in the B column what we will get, in the B column we have 6 minus, we divided it by 3 and multiplied by 4. So, 3 into 4 by 3, okay. So, we get 2. So, we get 2 here, okay. And similarly we subtract this row, okay. This row we subtract, okay, we subtract from the third row is this one, 1 2 0 1 0 0 3, from this we subtract. So, what we will get, we are subtracting now. So, this will become 0, right, this will become 0, yeah, this will become 0 here and then we will have here okay, here we have 2, okay, we have 2 here and after dividing by 3 it became 1 by 3. So, 2 minus 1 by 3 we will have. So, that will be 5 by 3, okay. So, that is 5 by 3 here and then here what we will have, this is 0, okay, 0 minus 0 is 0 here. So, we have 0 here. Then in the S2 column what we have, S2 column here we have 1, okay. So, 1 minus 0 will remain 1. So, that is 1 here. Under A2 column what we will have, A2 column here it is 0, okay. And here what we did was we divided by 3 and then after dividing by 3 we are subtracting. So, this is 0, okay. So, this will remain 0 and then what we will have here, here we have 3, okay. After dividing by 3 it became 1. So, 3 minus 1 is equal to 2. So, we get 2 here, okay. Now, what we have, let us find Zj equal to Cb into Xj. So, minus 2 into 1 is minus 2, minus m into 0 is 0, 0 into 0 is 0. So, total will be minus 2, okay. So, this is minus 2 here, then minus 2 into 1 by 3, minus 2 by 3 we have, okay. And then we have minus 5 m by 3 and then 0 into 5 by 3. So, we have 0. So, total is minus 2 minus 5 m by 3. So, we get this and then similarly minus 2 into 0 0, minus m into minus 1 is plus m, 0 into 0 0. So, we get m here and then this is 0, this is 0, this is 0. So, we get 0 here and then we have minus 2 into 0, minus m into 1 minus m, 0 into 0 0, so we get minus m here. Then minus 2 into 1 is minus 2, minus m into 2 is minus 2m, and 0 into 2 is 0. So, we get minus 2 into minus 2 minus 2m. Okay. Now, let us see, we find Cj equal to Cj minus Zj. Okay. So, Cj is minus 2, when we subtract Zj, which is also minus 2, we get 0 here, and then minus 1 minus of this quantity, minus of Zj, makes it minus 1 plus 2 by 3. So, minus 1 by 3 plus 5m by 3, and then here 0 minus m. So, we get minus m, 0 minus 0 is 0, and then we get minus m, and we subtract minus m. So, we get minus m plus m. So, that is we get 0 here, and we notice now that since m is large, okay, since m is large, minus 1 by 3 plus 5m by 3, this is a positive quantity. Okay. So, Cj is greater than 0 in the column corresponding to x 2, okay, and therefore, this is our key column. This is our key column, and in the elements of key column are 1 by 3, 5 by 3, 5 by 3. So, we divide the elements of B column by the corresponding elements of x 2 column. Okay. So, 1 divided by 1 by 3 gives you 3, okay. 2 divided by 5 by 3 gives you 6 by 5, and 2 divided by 5 by 3 again gives you 6 by 5. Now, we see that we have to find that value here in the theta, in the column corresponding to theta, which is the minimum, but 6 by 5 and 6 by 5, there is a tie here. Okay. These two values are both equal and they are less than 3. So, which row we will take as the key row? Because we want to get rid of the artificial variable a2, okay. So, we have to take this row as key row, okay, this one, because if we take this as key row, then a2 will be going out, and we will get at the intersection of a2 x2 will be coming in, okay, and this will be our key element. This will be our key element, x2 will come in place of a2 and a2 will go out. The column corresponding to a2 will be will no longer appear now. So, we now so this new simplex table, in the new simplex table what we will have? We will have x1 in place of a2, we will have x2, then we will have s2 here. The coefficient of x2 is minus 1. So, minus m will be replaced by minus 1. So, let us see the new since Cj is positive under x2 column, this is not an optimal solution. We introduce x2 and drop a2, and then the revised simplex table is like this. So, x1, x2, s2, the coefficient of x1 is minus 2, coefficient of x2 is minus 1, coefficient of s2 is 0. So, now our basic variables are x1, x2 and s2. This is x1, this is this is x2, this one is s1, s2. Okay. So, a1, a2, the two basic variables, the columns corresponding to basic the artificial variables are not there. Now, let us see, we have the new simplex table. In the new simplex table we have 1 1. Okay. So, we see what we have now. Yeah. So, this is our 5 by 3. Okay. We divide this equation by 5 by 3. Okay. This row we divide by 5 by 3 to bring unity here, and then subtract after multiplying this by 1 by 3, we subtract from this row, and subtract multiplying by 5 by 3, we subtract from this row to make this element 0, this element 0, that is we are doing elementary row operation. So, let us first divide this key row by 5 by 3. When we divide key row by 5 by 3, what we get? We get this one 0 1, okay, and 5 by 3 we are dividing. Okay. So, we will get here minus 3 by 5. Okay. So, that is minus 3 by 5 here, and then this one is 0. Okay, this one is 0, and then here 2 we are dividing by 5 by 3, so it will become 6 by 5. So, this is 6 by 5. Okay. Now, we subtract this row. This row is the row which will be with the help of which we will make the entries this ones 1 by 3 and 5 by 3 as zeros. So, what we do? We multiply it by 1 by 3 and subtract from the this row, from this row. So, what we will have? We have 1 here, okay. 1 here, and here we have 0. So, we are multiplying by 1 by 3 and subtracting. Okay. So, 1 minus 1 by 3, this is 0. So, 0 into 1 by 3 is 0. So, we get 1 here, okay, it is unaffected. Here what we will have, this 1 by 3. We are multiplying after making this entry as 1, after making the key element as 1, we are multiplying by 1 by 3 and subtracting. So, we get 0 there, okay. And here what we will have, this became minus 3 by 5, right. This became minus 3 by 5. So, we are multiplying by 1 by 3 and subtracting. Okay. So, minus 3 by 5 into 1 by 3 equal to minus 1 by 5. Now, this quantity we have to subtract from 0. Okay. So, what we get 0 minus 1 by 5, which is equal to 1 by 5. So, we get 1 by 5 here. Okay. And in the S2 column, let us see what we get here. We are dividing by 3 by 5, 5 by 3. So, this became 3 by 5, right. This became 3 by 5. No, A2 is not there. We come to this one. Okay. So, we are dividing by 5 by 3, this becomes 6 by 5, and then we are multiplying by 1 by 3 and subtracting from this row. So, we get 1 minus what we have, 1 minus 6 by 5 into 1 by 3. 6 by 5 into 1 by 3. So, we get 1 minus 2 by 5, which gives us 3 by 5. Okay. So, this is 3 by 5. Okay. Now, what we have to do, so now we have to make this entry 0. Okay. So, we have to multiply this row, we have to make this entry 0. So, we have to make this, we have to multiply this row by 5 by 3 and subtract from the third row. Okay. So, let us see what we will get. So, here this is 1. Okay. We are multiplying by 5 by 3 and subtracting. So, what will happen, this will remain 0, this will remain 0, this will become 0, and here what we will have 0 minus, we divided it by 5 by 3. So, it was minus 3 by 5, okay, minus 3 by 5 into we are multiplying by 5 by 3 and subtracting, hai. So, this and this what we have here 0 plus 1. So, this is equal to 1 I am getting. In the column S1 this is 1, okay, and in the column S2 what we will get here, this is 1, okay. We divided it by 5 by 3, okay, we divided it by 5 by 3, this become 0, this is 0, and so what we get here now, why we are multiplying by 5 by 3, okay, we are multiplying by 5 by 3 and subtracting. So, 5 by 3 when you multiply and subtract, what we will get, this is 0 here, okay. So, multiplying by 5 by 3 and subtracting from 0 will give 1. So, this will remain 1, okay, this will remain 1, and what we will have there, this element will become how much? We will have 2 minus this was 6 by 5, okay, 6 by 5 into 5 by 3. So, we get this. Okay, 2 minus 2 equal to 0. So, this becomes 0. Okay. Now, let us find Zj. Zj equal to minus 2 into 1 minus 2 minus 1 into 0 0, 0 into 0 is 0. So, total is minus 2. Okay. Then minus 2 into 0 is 0, minus 1 into 1 is minus 1, 0 into 0 is 0. So, we get minus 1 here, minus 2 into 1 by 5. So, we get minus 2 by 5. Minus 1 into minus 3 by 5 is 3 by 5, and we get 0 into 1. So, we get 3 by 5 minus 1 by 2 by 5 is 1 by 5. So, we get 1 by 5 here, and then minus 2 into 0 is 0, minus 1 into 0 is 0, 0 into 1 is 0. So, we get 0 here, and then minus 2 into okay. So, now let us see. So, we have got these values. Okay. Now, yeah, so this CB in the B column what we will get, minus 2 into minus 3 by 5. So, minus 6 by 5, and then minus 1 into 6 by 5. So, minus 6 by 5, and then we get 0 into 0. So, we get minus 12 by 5. So, this is minus 12 by 5. Now, let us see Zj we subtract from Cj. So, minus 2 minus of minus 2, that gives 0, minus 1 minus of minus 1 gives 0, 0 minus 1 by 5, minus 1 by 5 we get, and then we have 0 minus 0 is 0. Now we can see Cj is less than or equal to 0 for all j. Okay. Cj is less than or equal to 0 for all j. So, none of Cj is positive, and therefore, we get the optimal solution. An optimal basic feasible solution to the problem is therefore x1. What is x1? x1 equal to 3 by 5. Okay. So, x1 equal to 3 by 5, x2 equal to 6 by 5, x2 equal to 6 by 5, and z equal to minus 12 by 5, z equal to minus 12 by 5. Okay. Now, so maximum of z dash is minus 12 by 5. Okay. That is maximum value of z dash. So, minus 12 by 5, and minimum of z is what? Minimum of z equal to minus of maximum of z dash. Okay. So, minus of minus 12 by 5. This value is nothing but maximum value of z dash. Okay. Because we have converted the problem to maximization. So, after Cj is less than or equal to 0 for all j, the value of zj gives the maximum value of z. So, we get z maximum value of z dash is minus 12 by 5, and that is equal to so the minimum value of z is minus of maximum of z dash, which is 12 by 5. So, thus we get the solution of the given problem, where we find that x1 is 3 by 5, x2 is 6 by 5, and the minimum value of the objective function is 12 by 5. Let us take another problem. Maximum value of z equal to 3x1 plus 2x2 subject to the constants 2x1 plus x2 less than or equal to 2, 3x1 plus 4x2 greater than or equal to 12, x1 x2 greater than or equal to 0. Now, we have to express the problem in the extended form. Okay. Since it is already a maximization problem. Okay. So, it will remain as such. X1 x2 are greater than or equal to 0, 2x1 plus x2 is less than or equal to 2. So, this is constant is less than or equal to type, less than or equal to 2 type. So, we will write we will convert it to inequality by writing 2x1 plus x2 plus 0 into we have to consider a select variable. So, 0 into s1 and then equal to 2 it becomes, but here we have 3x1 plus 4x2 plus greater than or equal to type, it is greater than or equal to type. So, we get this is s1. So, we have to add a select variable here, 2x1 plus x2 plus s1 equal to 2, 3x1 plus 4s2 for x2, now it is greater than or equal to 2. So, we write minus s2 here, minus s2, we have to subtract a surplus variable. So, minus s2 equal to 12. Now, we have to add in order to get initial basic feasible solution, we have to consider select variable, the artificial variables also. So, we will write z equal to 3x1 plus 2x2 plus 0 s1 plus 0 s2, and then we have to add one artificial variable here to make, because this is greater than or equal to type. So, we get one artificial variable here plus 0 into a. Okay. So, artificial variable is given as minus m penalty. So, minus m into a we will have. Okay. So, objective function z equal to 3x1 plus 2x2 will be written as z equal to 3x1 plus 2x2 plus 0 s1 plus 0 s2 minus m into a, and here we will have 2x1 plus x2 plus s1 and then 0 s2. Okay. 0 s2 here we will have 0 s1 and 0 a here. Okay. So, these equations will now become 2x1 plus x2 plus s1 plus 0 s2 plus 0 a equal to 2, and 3x1 plus 4x2 plus 0 s1 minus s2 plus 0 into a equal to, no, not 0 into a, we have to add A, artificial variable we have to add. So, A, okay, equal to 12. Now, we have the objective function will be written as 3x1 plus 2x2. We will have two variables S1, S2. One is S1 is select variable, S2 is surplus variable, and one artificial variable A we have, which is given a penalty minus m. Okay. Now, this artificial variable comes because of the fact that the second inequality is greater than or equal to type. Okay. So, the first inequality is less than or equal to type. So, we have 2x1 plus x2 plus s1 equal to 2. Okay. But s2 and a are also there. So, we give 0 s2 plus 0 into a, we add them, and here 3x1 plus 4x2 and then 0 s1 and we subtract surplus variable s2. So, minus s2 plus artificial variable a equal to 12. Okay. So, now here we can say x1, x2, s1, s2 and a all are greater than or equal to 0. So, we get this equation, this maximum value of z 3x1 plus 2x2 0 s1 plus 0 s2 minus m into a subject to 2x1 plus x2 plus s1 0 s2 0 a equal to 2, 3x1 plus 4x2 0 s1 minus s2 plus a equal to 12, x1 x2 s1 s2 and a greater than or equal to 0. Now, we will find the initial basic feasible solution. Now, s2 is not a basic variable because its value is minus 12. We can see here there are two equations, okay, 1 2, okay, and 1 2 3 4 5 variables are there, x1 x2 s1 s2 and a. Okay. So, 3 variables can be chosen arbitrarily. So, we can, if we choose x1 x2, x1 equal to 0, x2 equal to 0, okay, and a equal to 0. If we take x1 equal to 0, x2 equal to 0, a equal to 0, then from this equation what do we get? S2 equal to minus 12. Okay. So, if we choose variables x1, x2 and a equal to 0, we get S2 equal to minus 12, and but S2 cannot be minus 12. Okay. S2 is it is not a basic variable because its value is minus 12. Negative quantity is not feasible. So, S2 must be prevented from appearing in the final solution, and therefore, we take S2 equal to 0 from the initial solution. So, we take S2 equal to 0. So, what we do? We consider x1 equal to 0, x2 equal to 0 and S2 equal to 0. Okay. And when we do that, we have this initial simplex table. Cj's are coefficients of x1, x2, s1, s2 and a in the objective function. This is CV column where now basis variables are s1 and a, and non-basic variables are x1, x2 and s2. Okay, x1, x2 and s2. So, the coefficient of s1 in the objective function is 0, coefficient of a in the objective function is 0. We then calculate zj equal to sigma cb aij. 0 into 2 is 0, minus m into 3 is minus 3m, their total is minus 3m. Then C 3 minus of 3m is 3 plus 3m here, and this becomes 2 plus 4m here. Here it is 0, here it is minus m, here it is 0, and this is 0 into 2 is 0, minus m into 12 is minus 12m. So, this is minus 12m. Now, we can see Cj is positive in the column corresponding to x1, in the column corresponding to x2, but m is large. So, we can say 2 plus 4m is greater than 3 plus 4m. So, this is our key column. Okay. Now, here what do? We divide the elements of B column by the corresponding elements of x2 column. So, 1 when divides 2, what we get is 2, and 4 when divides 12 we get 3. So, minimum value is 2. So, this is our key row, this is our key row, and when this so this is our key element. Okay. Now, x2 will s1 will be replaced by x2. Okay. x1 will be outgoing variable, s2 will be incoming variable. So, in place of s1 we will have x2, and here the coefficient of x2 will come, that is 2, and we get this table 2 x2 minus m a, and then we get this table. Okay. So, 2 1 1. Okay. Now, what we do? We divide the element the key row elements by this key element. Okay. So, when we do that, it is 1, 1 divides these elements, so they are unaffected. So, we get the same elements, okay. We get these same elements, and then with the help of this key element, okay, with this help of this element 1, we make this element 0, okay. To make this element 0, what we do? We have to multiply this row, the elements of this row by 4 and subtract from this row, okay. So, we have to multiply it by 4 and subtract from the elements of the second row. Now, coefficient of x 1 is 2, and here the next coefficient of x 1 is 3, okay. So, 3 minus 4, okay. We are multiplying by 4. So, 2 into 4 is 8. So, 3 minus 4 is minus 5. So, we get minus 5 here, this is 0, and this we get as what? We get here, we multiply by 4 and subtract, okay. So, minus 4 we will get. So, this is minus 4, and here what we will get? We multiplied by 4 and subtract from here. So, 2 into 4 is 8, 8 when subtracted from 12 gives you 4, okay. So, we get 4, and then we again calculate Zj, Zj is 4 plus 5 m, this is 2 here, this is 2 plus 4 m, this is m, this is minus m, and here we get 2 into 2 is 4, minus m into 4 is 4 minus 4 m. So, we get 4 minus 4 m. Now, this is Cj minus Zj, we find Cj minus Zj, this is minus 1 plus 5 m, this is 0, this is minus 2 plus 4 m, this is minus m. So, Cj is less than 0 for all j, okay. Cj is negative, an artificial variable, but what do we notice? An artificial variable a appears at non-zero level, you see in the B column, this is 4. So, this artificial variable appears at non-zero level, therefore, there exists a pseudo optimal solution to the problem. So, that is all in this lecture. Thank you very much for your attention.